Welcome everyone. In this video we are going to be exploring what the Pythagorean theorem is and how we can use it to help us solve different problems in math. So I want to draw your attention to the Pythagorean theorem right here. The Pythagorean theorem is a squared plus b squared is equal to c squared. And if I just randomly said that to you, you or we wouldn't know what it would mean if we don't know the different parts. If we don't know what the different parts are, like the A, the B, and the C, we wouldn't know how to use it. So let's explore those parts. So I want to turn your attention to the right of this figure of a right triangle. So remember, right triangles have the 90-degree angle in the corner. So in a right triangle, the side across from the right angle is known as the hypotenuse. So this side is across from the right angle, and we denote that with the letter C. And we can see that in the Pythagorean theorem, we have the letter C. So that C is referring to the hypotenuse. Now, let's turn our attention to the two other sides of the triangle. And the two other sides of the triangle are called the legs. And one leg is labeled as A, and the other leg is labeled as B. So if we go back to the Pythagorean theorem, we see that there is indeed an A and a B that are referring to the legs of a right triangle. So the Pythagorean theorem is saying that the square of A of the first leg plus the square of the second leg, B, is equal to the square of the hypotenuse. And so the purpose of the Pythagorean theorem is we use it to find the missing side of a right triangle. So let's see exactly how we do this in an example problem down here. So before we start figuring out what we should do in this problem, I encourage you when doing these problems to write the theorem to start. Write the equation a squared plus b squared is equal to c squared. So now I need to identify and label my sides so I know what I need to solve my equation for. Well, if I look at this figure, I see one side has length 3 right here, and I see that the other side has length 4. And I realize the side I don't know the length of is my hypotenuse, which I label C. So I know that I'm going to be solving my equation for C because I want to find the length of the hypotenuse. So now I need to label my legs so I know what numbers to put into my formula. So I'm going to have A equal to 3 and B equal to 4. So now I'm going to plug those numbers into my formula so I can solve. So I have 3 squared plus 4 squared is equal to c squared. And I got those numbers from this figure I was given. Okay, so 3 squared is 9, plus 4 squared is 16, and I'm still left with that c squared because that's what I'm solving for. 9 plus 16 is 25, is equal to c squared. Okay, so this is where you all will be using what you learned in the last unit about working with radicals and solving equations with radicals. So since this exponent up here is a square, is a 2, we have to take the square root of both sides to undo that exponent. So we're left with just a c on the right side, and then the square root of 25 is plus or minus 5. So we have that c can equal -5 or 5. Now I want to point out to your attention is that it does not make sense to have a negative distance. If you think about measuring something with a ruler or a meter stick, you don't come up with negative distance. It doesn't make sense. We measure distance in positive numbers. So since we're looking for this positive distance over here of the hypotenuse, we can ignore the negative and say that C is equal to 5. So my C, I found, by using the Pythagorean theorem, I found that our hypotenuse is equal to 5. So I know I just went through a lot of different steps, so let me recap real quick for you all. So I first started by writing an equation. And when solving these types of problems, you will start with the Pythagorean theorem of a squared plus b squared is equal to c squared. And I knew that I had to use that formula because when I looked at the figure I was given only the 4 and the 3 to start with. I was only given this information right here. I didn't know what c equaled yet. So I knew I needed to use the Pythagorean theorem to find the missing side of the right triangle. So after I wrote the equation, I identified and labeled the sides. So I labeled my 3 as my A value and my 4 as my B value. Okay, so I have one leg is equal to 3 and one leg is equal to 4. Now I want to point this out to you all. It does not matter whether what leg is labeled B and what leg is labeled A, because this addition right here is commutative. Okay, we will end up adding these two numbers together, the squares of those numbers. So it doesn't matter if I started and put my 4 as equal to A and my B equal to 3. I would still get the same answer. What matters is that C always represents our hypotenuse, okay? I'm going to say it again. C is always equal to our hypotenuse. Okay, and that is by itself on the right side of the equation over here. Okay, so I wrote the equations, I labeled my signs. So once I labeled my sides, I can plug those numbers right into the formula and solve like you all have learned in the past how to solve an equation. So once I solve for the unknown and take the square root, I get plus or minus because we are taking square roots. And I choose the positive value for C because it does not make sense to have a negative value for my C, because C is a distance and distance cannot be negative. Okay, so on the right is the process of how to solve these equations, and that's a really the common generalized process that you all will be using to solve these types of problems. So before I let you go, there is one other thing I want to point out to you, and it's the term called a Pythagorean triple. And a Pythagorean triple is when all 3 sides of a right triangle are whole numbers. And what that means is when we look at this example we did, side A was 3, side B was 4, and our hypotenuse, side C, was 5. When you look at these sides here, there are no square roots involved, there's no decimals, there's no fractions, they're whole numbers. So we would label this group of sides as a Pythagorean triple. And it's just a special relationship when it works out where each of the sides is a whole number of a right triangle. When solving these, your answer doesn't have to turn out as a Pythagorean triple. It's just kind of a term mathematicians have created to identify this certain group of triangles, right triangles specifically, whose sides are whole numbers. And you will learn more about right triangles and different relationships that are involved further down the line. But what you need to know right now is that when there are the 3 sides of a right triangle are all whole numbers, it's called a Pythagorean triple. Okay, so that's it for this video. If we will be exploring more of this in class tomorrow, so come ready and prepare to learn more. Thank you.